This is the title of today's seminar. I will just say a few words about who we are and why we do this, maybe quickly, why we have this space. So Twin Politics is an ERC, that's the European Research Council Consolidated Grant, that's running until June 2029. And yeah, we basically research here how this digital twin of the ocean is being developed and how it could also permanently change the interface between science and politics, particularly at the case or on the case of a different intergovernmental or international negotiations and agreement making around ocean and environmental issues. So, for example, the Plastics Treaty, the Biodiversity by National Jurisdiction Agreement, and the Seabed Authority and CBD. And so this seminar series that you're now being part of is sort of complements our research work in that we, first of all, as researchers, would like to hear from other researchers what they are working on, and we really use this space to engage with others. But we also create sort of a space to exchange on scientific papers, but also for policy-related things, and also for NGOs. Whoever's interested in the topics can join and discuss, listen a bit and discuss. And now today we have the privilege to welcome Madhulika Bhati, and she's from Dalhousie University, or visiting professor at Dalhousie University, and also principal scientist at the National Institute of Science, Communication and Policy Research under the Council of Scientific and Industrial Research in India. So she's been studying the integration of digital twin technologies in blue economy sectors for a while, and this is why we also stumbled upon her paper and then decided to invite her to this seminar. And this really researches how these technologies are being used and applied in different blue economy sectors such as energy, shipbuilding, port operations, and so on. And yeah, we really look forward to listen to you and hear about what we can learn about applications of digital twin technologies and the landscape of patenting. There you go. Let me just move over. Yeah. Okay. I hand over to Madhulika, and I will then afterwards moderate the discussion or the question and answers if we have some. And yeah, I will be quiet now and hand over to Madhulika. Thank you very much.
Thank you, Arna, for a very nice introduction. And thank you, Phyllis, to helping me to share my slides. So good afternoon and good evening, everyone. Although Arna has already nicely introduced me, so I am Madhulika and I am currently a visiting professor in the Department of Industrial Engineering at Dalhousie University in Canada, and I'm a principal scientist in Council of Scientific and Industrial Research, National Institute of Science, Communication and Policy Research in New Delhi, India. So this presentation is a part of the research conducted under the Octopus project. This project is a ocean communication technology and ocean going platform and underwater survey, which is a key initiative within the Transforming Climate Action Program at Dalhousie University. The project is led by Professor Ronald Palo and Professor Flores Golande, and it's aimed to advance technology that supports sustainable ocean operation and climate resilience. So today I will take you through 5 key points. Next, please. So first, we will get a quick overview of what the blue economy is and the main sectors within it. Then we will look at how digital twin technology are developing and their different stage of maturity. And after that, I briefly explain the patent scope database and the international patent classification, which we are using in our current research, which help us to study the innovation dynamics of digital twin technology in the blue economy sector. And next, I will go over the result and discussion of our current analysis. And finally, I will talk about the future direction and what the next for this research. So next, please. So if we if want, because the blue economy is a very buzzing word, and still there is a lot of definitions, but several international organizations like World Health Organizations and Organization for Economic Cooperation and Development have defined the term blue economy. In general, we can say the blue economy include both established or traditional and new ocean based activities. So traditional sectors are the well-known sectors that rely on the ocean, such as marine energy systems like offshore wind turbine and tidal energy, shipbuilding and building and sea operation, fisheries, aquaculture, and other emerging sectors. These are the areas that focus on sustainability and innovations, including coastal protection, biodiversity conservations, and the deep sea mining. So, overall, the blue economy cover all the activities that use ocean resources responsibly, whether they are long established industry or the new areas. Next, please. But when we come into here, I try in our research what we trying to be captured, that how the digital twin is related to our transport climatic actions program going on in Dalhousie University, that has three main objectives: reduce uncertainty, mitigation of climate change, and develop adaptation solution for this one. And using the digital twin in across the blue economy sector, that are marine energy systems, shipbuilding and port building, aquaculture and fisheries, and other ocean ecosystem, that is ocean health, marine litter, sea level rise, such kind of current issues going on, how the digital twin is able to address all of these challenges in this uh, through the spectrum of all this blue economy sector. So next, please. If we look at the digital twin, it looks like that it's a very novel concept, but maybe it sounds like it's a very new innovation, but it actually evolved gradually from several earlier technology. It built on decades progress in digitalizations, computer modeling, and the data integrations. So we can think of this journey in four main stages. Like the first stage was the digital enablement, where organization began converting paper-based information into digital form. This didn't change how process worked, but it helped store and manage information more easily. Then next came the digitalization assistance added during the 1980, where engineers started use computer tools like computer aided design, computer aided manufacturing, which allowed them to design and test products virtually before they were built. So this was an important step towards simulations and the virtual modeling. The third stage was the digital control and link, came into 1990 with the expansion of the internet. It connected systems and people globally, making it possible to monitor operations remotely and create new value chain through digital platform. And finally, in the 21st century, we entered the era of cyber physical integrations, a time when the physical and digital world merged with technologies such as Internet of Things, cloud computing, big data, and artificial intelligence. And we can now create real-time virtual replica of a physical system. These are what we call the digital twin. So next, please. So basically, we can say the digital twin, they provide a unique mean to achieve the cyber physical integrations, which is notion embraced by more and more enterprises. DT means, and you can say that the whole of physical asset as well as its digitized representation, which mutually communicate, promote, and co-evolve with each other through bidirectional communication. So bidirectional communication or interaction is a main, it's a very important characteristics of a digital twin. So through various this technology, this entirety or behavior or the relation in the physical world are digitized holistically to create high fidelity models, and such virtual model depends on real world data from the physical world to formulate their real-time parameter, boundary conditions, and the dynamic, which leading to a more representative reflection of the corresponding physical entity. Here I try to be sure that that was the first mirroring model is given in 2000 by the NASA, where they have shown that real space, how we can mimic this real space with the virtual space, data first transfer from the real space to virtual space, and there is a bi-directional link where the information goes back to the physical. So basically parallelly they both behave like in the same manner. So somehow the virtual space exactly behave and looks like a real space. As there is just some more little bit upgradation happen, which can be seen in the next slide, where they have please next slide please. In this one, the Tau recently has given this kind of real space and the virtual space linkage in the specifically for the wind turbines, where they so several iterative optimization take place, historical data, and with the help of historical data and sensors, the all data goes to the virtual space, and simulation and modeling and several scenario has been created with the help of the core enabling technology, and that's how it's work. And it's a kind of a closed loop kind of system where the communication in a bi-direction happens. Next slide please. So if you look at this is the one another paper I just want to show. It looks a very interesting slides in that way, that in the digital twin it looks like a one individual technology, but to make a digital twin several core technology is required. That technology falls in in several category. They are the visualization and operational technology, analysis technology, multidimensional modeling and simulation technology, connection technology, synchronization technology. So, and this digital twin, from the application point of view, it's penetrating several industrial sector from manufacturing, defense, livestock, medical, and also our blue economy sectors. So uh, this thing shows that the complexity, heterogeneity of this digital twin, and also show that digital twin doesn't build in a one day. It's a gradual evolving evolution of this digital twin from the other core technology like artificial intelligence, machine learning, and another Internet of Things, etc. Next slide, please. And then this complexity of digital twin further increased because now the current literature say that digital twin, based on their functionality, can can have different stages of maturity. The one recent paper, one paper just come where they have shown the 5 stage model of digital twin, where they are saying the first stage is the mirroring stage. In the mirroring state is just where there is a no bidirectional communication, but it's just the mirroring, the duplicating a physical object into a physical object. Monitoring is like that, if one further step ahead and one upgradation in the functionality, where it mirror the physical to physical space, but also monitor and controlling the physical object based on the analysis. And third step is the modeling and simulation, where beside monitoring and controlling, it will also have to optimizing the physical object through the simulation result. And third is a federation, where the real communication happens. It configures the federated digital twin, optimizing complex physical object and interoperating federated digital twin. So at the more advanced stage is the autonomous stage. It's autonomous stage is where autonomously they recognizing and solving problem in federated digital twin and optimize physical object. So in terms of the functionality, it's a kind of that it's further categorization in the five more subcategory, uh, which make it which so that we can easily see the complexity in the digital twin characterizations. And then please next slide. In this slides, this four has done a seminal work, and this example he has given is a 6-stage maturity level, where it starts from the level 0 to level 5. In the level 0, it mentioned that at level 0 it starts with a stand-alone model. It's just a digital version of an asset that not yet linked to real data. So they put this kind of model also in the digital twin 0 level. For example, if we take an example of wind turbine. So if the 3D model of wind turbine, uh, which is not yet before it built, is comes under the stand-alone digital twin. Even it's not connected, it's just the digital version of that wind turbine. And in the level 1, what they want to say that the model becomes descriptive. It means it receives data and can show the current condition of the wind turbine or real object, any real object. Level 2, which they mentioned like a diagnostic, is able to uh, detect problems and help with troubleshooting, like identifying why the turbine isn't performing well, kind of thing. And level 3 is a predictive, where the system use data to forecast what might happen in the future. You can say, for instance, predicting the maintenance, when the maintenance will be needed in the wind turbine. So at level 4, it's a prescriptive. Here the digital twin not only predict problem, but also recommend the best solution using the what if scenario analysis. And finally, the level 5 is a autonomous, the most advanced stage, and the system can make its own decision and take action automatically and without human inputs. So this kind of different stages has been cited by several researchers now in different domain and different blue economy sector research. So overall, what we can say that as we move from level 0 to level 5, the digital twin evolves from a simple static model into a smart self-learning and autonomous system that support better decision and efficiency. So with this one, these are the motivation that digital twin technologies are addressing the several challenges in the blue economy sector, and there are several narrative reviews and papers about how the digital twin is developing in blue economy sector, in which academic research is reviewed, but there is a lack of article which providing a comprehensive view of the DT patents in the in blue economy sector. Because with the integration of digital twin innovation into the blue economy sector, it is important to understand the innovation landscape in this area. Whereas I agree that analysis of scientific academic publication provide insight into recent research trend, but all the blue sky research doesn't always promise innovation and real world uptake. So patents are the more important indicator of the maturity of a concept and show a higher degree of technology readiness level. So it's provide more direct insight about the technological innovation and the near-term commercialization of new technology. So patent landscaping analysis, it can offer more insight about what kind of commercialized technology are exist, digital twin technology are exist across the blue economy sector. So with this aim, this study has been undertaken to know about the digital twin innovation landscape in blue economy sectors. From With this ongoing research, we try to be address a few research questions. What is the geographical and temporal distribution of these patents? Who are the prominent actors in terms of industry, university, and R&D institute, and in terms of country who are playing crucial role in advancing the development of implementation of digital twin in the blue economy sector, and what kind of existing state of art of core digital twin technology, and what kind of challenges they are addressing in domain which is specific, especially in the blue economy sector. Next, please. So for this one, we use a simple methodology. In our earlier work, what we have done, we developed some Boolean key string, and we have tried to be capture the research trend through the publication analysis using the scientometric approach. So that Boolean key string we also applied using this patent scope. The patent scope is a patent database. It is a valuable resource, and it's cover over 60 million patents in the database. It offers useful machine translation tool that help user access patent file in different language more easily, because the patent it just depends is filed in several language. Maybe English is maybe the dominant language, but some regional patents also in the native language. So this patent scope has a machine translation tool which easily convert the patent description in English, which can easily readable and accessible to us. And so we use this Boolean key string approach, and we retrieve the patent across various blue economy sectors, especially the marine energy system and shipbuilding and ship operation, fisheries and aquaculture. So with this one, the statistics was that we got almost 130 patent in marine energy system, and almost 235 document is retrieved in the shipbuilding and sea operation. However, in the fisheries and aquaculture, we only able to be get very less. First, we try aquaculture and fisheries in a separate key string, but we have seen a large portion of overlapping was there in the aquaculture and fisheries. Then we combined both the sectors together, and all together we able to be retrieve only the 21 patent in this one. And so that's how the patent data this all data set we extracted in a CSV files, and these files contain very important information about the patent file number, who are their inventor, who are the applicant, what is the patent filing date, grant date, and international patent classification, and what the title of that patent, and abstract and description. So that patent scope is a free online patent search system that provided by WIPO and giving access to publish international application. To organize and classify these patent scope use the international patent classification system. It's a global standard that group invention based on their technical field. So IPC system is structured like a hierarchy, starting from a broad categories and narrow down to specific details. So broad categories start with the section which is shown in this slide, like a section A, B, C, D, E, F. There are 8 sections. I only see the 6th section over here. So there are total 8 sections. It starts with a very broader concept. So if you want to be look at some kind of a medical device patent, so you can start your research to be look at the section A, which covers the agriculture, food, medical portions. So that's how it's work. And the patent scope uses IPC code. So IPC codes to classify documents. So there is a one way, if you want to search a specified documents, you can easily get the IPC code of this one for that particular document. So this is like from the section There are 8 sections. Then each section divided into class. Would you please next slide? In this class, if you say the section will again has several classes, so it will be like that. If the section is G, then there will be a double-digit number will be there. So it will be a class like in the 2-digit number added to a section letter. So it will be G06, and then the each class has several subclasses. So one capital letter added to the class. Then in this case is F, and so it will be it is a subclass, and then each subclass is divided into group, and this group we have a main group where we generally indicate by 00, but in each group there is a several subgroups, so we can say like there is a 4 or 5 subgroup in this particular uh, particular section, class, subclass. So that's how this layered structure help us to search more precisely. So that's as I give a earlier example, that if you want to be interested in medical device, you might start with the section A, human necessities, then narrow down to class. You can go for there is another class where you can go for the class level, subclass level, then group and subgroup level. So it's if you want a granular detail, so we need to be work on a level, on a subgroup or group level. Next slide, please. So based on this kind of strategy we have adopted, and for the marine energy sector, we have seen that although our time span was 2012 to 2000 for the current year, the basic understanding was that because the blue sky research or the research activity or publication activity start in 2000 in 2008 onwards. So our our thing is that to establish a proof of concept, it generally take 2 to 3 years from the research to start, from the conceptualization to establish a proof of concept. So we started our to extract the patent from 2012 to 2000 for the current year. But still, when we see that even we give this time span, but most of the patent start to evolve from 2015 in marine energy sector, and it has gradually increased in the patent, and in 2024 it's a patent number is quite enhancing. And in terms of the country distributions, the main China is dominating in this one. China is accounting more than 90% of the total patent activities, and other emerging other leaders are the Republic of Korea, United States, and Australia. So if we look at in terms of the industry, institute, and university, in that we found that most of the top leader, the top lead, although for this 130 patents, almost 58 university, institute, and industries are involved. We took those industry, institute, or university which have more than 5 patent in their account. So based on that, we could find these 6 bit. Most of them is in the China and in Korea. So there is a one this China National Offshore Oil Corporations and its subsidiary, they have a most patent, and other leading industries, a university, and the industries are the North China Electric Power University, China Three Gorge Corporation, Korea Shipbuilding and Offshore Engineering. So it's a combination of industry and university. Overall, the industry, most of the research in this area is industry-led, but university is also emerging and come up with several innovations and several patents. Next, please. Then we went to the then we have explored the IPC classification classification code, and we have seen that what kind of innovation and what kind of challenges they are addressing these patents. So we have seen that innovation in marine energy sector is concentrated in key area: wind turbine, wind farm, offshore structures, and offshore wells. Wind turbine has emerged as a focal point with digital twin technology it's applied to turbine and their critical component. And wind turbine, like a wind turbine generator, blades, and the structural framework. And we have seen that most of the time the identified application of DT or digital twin is to tackle various area like a fault detection and prognosis of recognizing, anticipating failure in wind turbine operation, which help minimize the downtime and boost reliability. Apart from them, there is a uh, other challenges. They address the remaining useful life of the wind turbine, and structural health monitoring area is captured by the digital twin. And same also the digital twin is not developed on a system level like a wind turbine, a digital twin of a wind turbine or digital twin of a wind farm, but also on a subcomponent level like a digital twin of wind turbine blade, digital twin of wind turbine Nestle. So it's a innovation is happening on a subcomponent level or as well as a whole system level. Next slide. So here we try to be say that where the patent is filed by most of the country in which it, so basically the G level and the F level, these are the two section where the mostly the patent is filed, and it has given on a subgroup level. And if you look at the description of those section, it's mostly relate to the wind turbine and wind farm, either the monitoring of testing of wind motor, and also if you look at the G06F, it's more about the computational tools are applied or techniques are applied like machine learning, artificial intelligence, and neural networks. So it's give a whole understanding that how important this computational modeling is to develop the digital twin of in marine energy sector. Next slide. The same we have done for the shipbuilding and sea operations, where again we have seen that China is a more prominent leader, where 80% of patent filed by the Chinese industry, university, and R&D institute, and Korea, United States, and Belgium are the another leader who are filing this most of the patent, and most of the major leader or major actors again from most of them from the university. So the difference between marine energy sectors and the shipbuilding sector, that here I can see most of the universities filing the patent. Their industry is comparable at par with the university, but university is quite active in this sector. But marine energy, it was basically the industry-led research. Next slide, please. So again, if you look at the ship, the main area they are capturing, so the innovation in these sectors, it's concentrate on 5 areas. One is the ship navigation system, another is the ship firefighting and alarm system, and one more important area is smart fish ports, port operation efficiency, and digital twin based ship along with their maintenance and safety. So in ship navigation, the emphasis is on providing solution to prevent collision through real-time monitoring and optimization, significantly enhancing safety at sea. In other crucial areas such as fire protection and alarm system, innovation include environmental monitoring, fire location identifications, and escape route planning. Other significant focus area involve developing port efficiency system for streamlined logistic management and implementing intelligent scheduling. And further, it advances the concept of digital twin of ship and their subsystems. So covering the sloshing management, lubricating oil system, pipeline erosion or corrosion control, and automatic stacking device. So such kind of innovation or patenting activities in this area are happening. So next slide, please. Again, if you look at the in the terms of IPC classification code, again the section most of the patent is filed in a G section and the B sections. So that is mainly for the design optimization, design modeling architecture, or vessel tracking and forecasting, such kind of things. Because these classes are or subgroups are dealing with those things. So most of the patent filed in this one. So there is a one way, once we identified that the more the patent which we are interested in which section, in which subgroup, we can further go for a forward and backward, that we can capture that subgroup, and we can again go for a some kind of reanalysis, like that if anything skip using the Boolean key string, we can add the subgroup level IPC classification code along with the keywords, so it will give a more promising results. Next slide, please. So for the aquaculture, because we haven't get a lot of patent in the fishery and aquaculture, there are only 21 patent we have reported. So based on their title and abstract, we have created the keyword, and we're trying to be capture what kind of challenges these patent are addressing. So we have seen that for in the case of aquaculture, it's a kind of thing that fish farming and habitat management innovation are happening in this one. Uh, Also, there is some intelligent aquaculture farming, intelligent aquaponics related activities is going on for and for the health fish health monitoring tools has been developed. Digital twin is developed for the fish health monitoring, water quality, as well as to disease control. So these are the main area, and they are using it to reduce the cost and forecasting. In forecasting about the water quality and such kind of it's just a kind of overview, high level overview kind of thing. But and for the aquaculture net, net, if the net damage detection techniques has been developed with the help of this digital twin technology. So these are the 4 or 5 areas where the most of the patents are focusing. And others area, next slide, please. In this one, we try to be captured because there are only 5 or 6 patents for the emerging area. We couldn't find so many, but there are just 4 or 5 patent was there, which mainly all the patents were related to the deep sea mining. So we understand that deep sea mining for the environmental monitoring and what kind of damage is happening. And deep sea mining is like a to prepare where it's a very harsh condition, so it's a remote controlling of the all the machinery who are work on the seabed, such kind of, so that it can be optimize their efficiency, or if they can stuck with something in the on the seabed, it can be controlled remotely. Such kind of innovation are happening with the help of digital twin. So that's all. That a comprehensive overview of what kind of research this innovation hotspots are there, what kind of challenging they are addressing, and is the universe what kind of universities are there who are developing this patent, who are filing this patent, or industries are involved in this one. So with this research, we're trying to be captures such kind of scenario, so that we can get we can capture the innovation dynamic in this blue economy sector. So, but still, when we are going through this, such kind of other questions are emerging. Question are need to be answered. Like next slide, please. Like one question is related to the conceptual and terminological complexity of digital twin research. So these are the food of thought that what I'm thinking, that the terminology ambiguity and but the original concept of digital twin, how we can extend it to in a ocean context, because the origin concept, which was when this term was coined by the by Professor Grieve, it was basically for the PLM, product management cycle. So if we talk in terms of a product, it's a static, so it's engineered and it's a control. But when we go to the ocean context, it's a dynamic. So how we will able to be extend this digital twin concept in ocean ecosystem? What kind of protocol we need to be perceive, or what kind of standards we need to be developed? Manufacturing, there is a well-established standards are there, but for the ocean ecosystem, because it's dynamic, it's natural. So how will we go about that? Further, there is another concept that now, based on the functionality, there is a layered complexity arise, like even they are saying, they are putting a physical asset. If you just made a replica for any physical asset, is it will be counted as a digital twin, or it's a level 1 or level 0. So how we will categorize the patent or any innovation, in which categories they are, and what is the best way to categorize a patent as per their technology readiness level, looking at their functionality. And third thing is, like we have seen that uh, diversity in the number of patent activities. Some established sector, blue economy sector like marine energy and shipbuilding and port building, we have a plethora of patent, but for the aquaculture and fisheries, we don't have. So what are the possible region? Is the region just a region, maybe it's a no innovation kind of digital twin happening, or maybe there's some other region, like people are going for the open innovation activities, or more collaboration and data sharing required, and also the cost associated with the patent. This answer we still are trying to research that, what are the possible reason, with the expert help, and on our secondary desktop research, and as well as the expert view. So next slide, please. Thank you for the listening, and now we can, discuss. Let's discuss together whatever the question. Yeah, we can discuss together. Thank you so much.
Yeah, thank you very much, Madhulika. Yeah, it was actually very interesting. It's good to hear the very concrete examples of how digital twins are being used. It's also something new, but it's also for us, but it's also something that is oftentimes seems very, very far away from our daily lives, you know. So it's really interesting to hear the actual applications and patents. So I have a couple of questions, but first let's open it to the floor, the audience, whoever has a question. Put it. You can put it in the chat, raise your hand, or switch on your camera and let me know somehow. Otherwise, yeah, there you go. Meisham, please, yeah. Maybe you can just quickly introduce yourself in a sentence or two, and then you can ask your question. Thank you.
Hello, can you hear me?
Yes, very well.
Hi, I'm Meisam. I'm a postdoc researcher from the MDU University in Sweden. So, first of all, thank you for your nice presentation. In this case, I just have one small question. From your point of view, what can be, or what is the position of developing new sensor as a low-cost sensor to launching a successful digital twin, especially in such a large area in our case like an ocean, because as you know, we have a lot of needs regarding the data collection. So there is such a kind of lack of data regarding the in situ satellite data and the LIDAR or GRIDAR. So I want to ask you, there is a room to developing such a kind of sensor as a low-cost sensor, and how we can use it as a patent. Thank you.
Thank you, Mason. It's a very quite relevant question about developing a low-cost sensor. It's the need of our. It's a kind of thing, because digital twin, if you look at the architecture of digital twin, so sensor is an integral part of this one, because the transferring of the data from the physical asset to the virtual asset, that that is the two kind of data. We give the historical data and the data we receive from the satellite. And you are right that it just depends on different domain, like which domain you are capturing. So low cost, there is a lot of, because we need a lot of sensors to capture the data. So low cost sensor is quite expensive part, and it makes the digital twin technology quite expensive. Because the cost is also one of the driving force to making our digital twin feasible in different sector. So what is my personal? It's just depend case to case, because definitely there is a first thing, the prioritization of what kind of sensor would be required to take capture of the data, and then the what kind of data we require, and for to capture those data, what kind of sensor we can use, and that sensor, what is the existing market of that sensor, and then we can say that uh, what kind of USP you can provide and developing a low cost sensor. There is a one thing, not only the low cost, because in case of digital twin, uh, more important is the quality of the data. Is this without compromising the quality of the data? If we can develop a sensor, that would be a good idea from my point of view. So some kind of holistic approach where without compromising the quality of the data, if we can develop some sensor of low cost, that would be good. And because it's a when we want to file the patent, that is the some kind of novelty and uniqueness should be there. If there is a patent with the same USP is already there, so we can't file the patent. But if some kind of novelty, not because cost is not the novelty factor to be a to become your novel technology. What I feel, the novelty or uniqueness in a of any low cost sensor would be like in terms of some kind of unique USP you develop for your sensor with maybe on the same coast which already the sensor exists, like that one. So I hope I give the answer of your question.
Thank you. Thank you
Yeah.
for your time.
Yeah, thank you for this very elaborate answer. Any other questions? Otherwise, I think, yeah, my first question was a bit regarding the results, and particularly the distribution of the patents. Did it surprise you that there was such a, yeah, almost domination of patent applicants from China? Yeah, so was it what you expected? Or did it surprise you? And how do you explain this distribution?
And it's a very interesting question, and that was also strike to me first when I started to be, started to explore the patent this database, that why the China is the dominant leader in this one. The one possible, but I say that the data was whatever the data is in the patent scope is there. Based on that and what kind of Boolean search string we have developed, and based on that one, China is coming as a prominent leader. But I want to be, because it's still a ongoing research. Every patent database has their own limitations. So there are several open platform which dedicated patent database like eSpaceNet is there, USPTO there. So what I'm trying to be capture the data from there, and then compiling a more comprehensive data set to be more dive into this one. But definitely one reference I really want to quote, which I also, the same question arose in my mind. There is a recently in 2025, there is a artificial intelligence index is published by WIPO, and I was quite surprising that, because digital twin is also a technology where we use artificial intelligence, machine learning, IoT as a core enabling technology to make digital twin. And in this 2025 also they address that China is the top leader in this artificial intelligence index there. So, uh, maybe we can, there are precedences there that such kind of computer enabling technology China is progressing well, but overall, but just that is, we need to be see that it's, these are the patent which are digital twin with the blue economy sector. But overall, if you see the digital twin technology, then the whole statistics will be changed. So we should not be confused it with the whole digital twin market. If you look at the whole digital twin market, then the top leaders, all the statistics, all the industry will become, other industry will become there. So that's how I can explain this in this. Yeah.
I think that directly relates to the question that Paul asked in the chat.
Yeah.
Said, thank you for the talk. Could you summarize who the most active countries and companies or universities are across the different technological fields? Yeah, because I think you showed them each separately. So maybe, yeah, which are then the overall the most active countries, companies, and universities?
So like I was only able to show you the few of them because our threshold was that at least the university and research institute who have at least published a 5 patent. Like there are, so in my initial in my talk, during the talk I have mentioned, suppose let's take an example of marine energy system. Although I showed you the six companies there, but altogether for this for in the patent, but the statistics I found that lot of university, more than 57 or 58 university, industry and R&D institute are there. Yeah, definitely most of them belongs to China. And apart from that, what I can say that between there, I have seen the between the collaboration between the university and R&D institute, because one patent filed by the several applicant, which from a mix of university, industry, and R&D institute. So that is the overall picture. But yes. If you, I can share you the whole kind of, if somebody wants more information regarding it, I can give you a list of top 30-40 that who are developing and main inventor, who are the inventor, like such kind of, and the whole description of whole patent. You can go through the whole patent, that what kind of technical field they are capturing.
Yeah, thank you. I hope that answers your question, Paul. Otherwise, it was just a question to share that PowerPoint, which I'm quite confident that should be possible, I guess. Are there any more substantive questions? Yeah, Paul says he's happy. That's good.
Thank you, Paul.
When
You
has
can
a
connect
question.
anytime if you want, then I will share with you the data. Don't worry.
Okay. Maybe, I don't know if Maysam, if you are already on our newsletter list. Otherwise, it would be good to drop your email address somewhere so we can contact you.
Honestly, I don't know, but thank you.
Yeah. Let me just send it to me or in the chat or something.
Okay. Thank you.
Can I go ahead with my question? Yeah, thank you, Professor Bhati. I have a question regarding to, I'm Wen. I'm also one of the PhD researcher with the Twin Politics team. And I have a question regarding to the methodology of this article, because you showed a slide comparing the publication-based analysis and the patent-based analysis. So from my understanding, does it mean those patent-based, like the digital twins that you discovered from patent analysis, they have a more like commercialization orientation. So the digital twins was invented to gain the profit. And I also think there are other types of digital twin, for example, they are invented to serve for the public interest. And then does it mean like this methodology somehow couldn't cover those digital twins that is non-profit? For example, the ministry invented a digital twin to predict the extreme weather. Would they be reflected in the patent database?
So, yeah, okay, it's a very good and relevant question. When in the patent database, it's a kind of thing I want to be, let me elaborate it. So, it just depends. Sometimes the innovation happens. It's not necessarily that everyone filed the patent to the patent office because there is a lot of cost associated with the patent filing. Second thing, the small enterprises or what you say, this ministry of some extreme weather database. So here our patent was limited to the blue economy sector. We capture the aquaculture fisheries, we capture marine energy system, we capture shipbuilding and port building, and you are talking about the extreme weather. So extreme weather, if you are saying in terms of marine energy system, that because wind turbines lives in a very harsh condition, extreme weather conditions there, definitely uh, our keyword, we have developed the keyword with the help of the expert like this, that we are gonna more focus on the marine energy sector, what kind of challenges they are facing. So suppose if you take an example for the wind turbine, and wind turbine lives in a harsh condition. Because of those hard conditions, some of the component of the wind turbines just need maintenance kind of thing. So maybe someone had developed some digital twin for the wind turbine for that particular subcomponent, which I have already I showed you in one of my slides. So that would be captured. But for a general extreme weather condition, you are saying that I'm afraid that because it's a kind of thing, because it's not comes under particular that domain. That is the one thing. Second thing, each innovation, everyone filed the patent because specifically in the ocean ecosystems or this blue economy sector, a lot of data sharing is happening. In the case of digital twin, its a model is more open innovation model is there, and the small enterprises are not in a position that they can bear the heavy cost of this patent. There is another way to protect their innovations by using licensing agreement kind of thing. So maybe it's just a limitation. It's just the kind of thing that innovation will be not captured by this database. Only the patent filed by some company industries in particular that area can be we can do the analysis based on that one only. I hope I'm able to give answer. Is it? Yeah.
I also have a follow-up event because you mentioned like this digital twins from companies, and then in China's case we see like there are a lot of universities. So did you do like specific case study? Like what is the situation? Does this university also collaborate with companies to, like, for example, get the funding and then invent digital twin to serve for the company's needs?
Yeah. So because our research is still going, still going on, and that the research I'm trying to be captured. That so far we have just do the geographical and temporal and the major innovation hotspots. So in a coming, this is my future scope of research where I am trying to be captured this main, innovation hub in China. How it's what kind of innovation dynamics are there, is a strong collaboration between the PPP, private, public, and like a university, industry, and institute linkages are there to develop this digital twin ecosystem specifically for blue economy sector. So it's an ongoing research. So that is an important question I would like to be highlighted in my future research. Yeah.
Thank you.
Yeah, excellent question, Wen. Thank you. Any other comments or questions from the audience? Otherwise, I just jump in quickly here because I was wondering if you also are planning to, if you have looked or are planning to look at the sort of interaction with governance systems or institutions. So whether you can see that patenting activity or the patenting landscape is influenced by certain governance bodies, or for example, you mentioned that regarding the environmental monitoring, they all are related to the deep sea mining. And is that sort of do you see an interaction with the governing body, the ISA there, and do you see it also in other areas that sort of how these are regulated has an effect on how or like the patenting activity?
Oh, it's a very important and relevant question, but right now, my main focus was to look at the overall innovation dynamic, capture those innovation dynamic through the patent activity. We so far we haven't looked at the governance part, that how the regulatory bodies are going to be, impact this innovation environment, or maybe to create some monopoly or oligopoly. I can understand for this one, but definitely the governance has a more driving force which created enabling innovation environment of any particular country overall. But as in the previous case, like in a nanotechnology or any emerging technology once it comes, so it just depends what kind of policy we have formulated, which create an enabling environment. But so far, I'm not a right person to give an answer, or it's not the right now. I'm not in a position, but definitely I will find it out, and will connect with you later on. Yeah.
Okay, yeah, that's fair. Maybe it's also something, I mean, it's also something we are interested in and trying to
Yeah,
find
it's
out a
a,
bit. And this
yeah,
is maybe
yeah,
also an indication that it's a good area to study for the
yeah.
future.
Because I would love to be, collaborate, because it's a really important question need to be addressed. Because yeah,
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 I guess it can sort of influence each other a bit
yeah,
both ways, no?
yeah,
What is
yeah, sure.
already the activity of the industry already kind of influences how the regulations may look like or how it will be governed, but also vice versa, as you said,
Yeah.
that the policies influence the.
Yeah, definitely, because China has their digitalized policies now, but it's just I'm not very much aware about the other countries, how the particular dedicated policies are over there. But China does have some
Mm.
digitalized strategies for a decade now. So maybe such kind of policies are already placed there in China in well advance. So maybe it's creating an enabling environment to do more R&D in this area, maybe. But need to be
No.
dig without before giving any answer. Yeah.
Okay. Any other questions here? Also, I thought it was very, just for ourselves, very useful to see the database you used, no? The what was it? The patent database, and that has the also the patent scope that has also the automatic translation between languages, because it's also something we struggle with and to find relevant research and patents in different languages. But it's good to know that this exists and you use it to also you search across languages.
It's like that. Suppose because whenever we choose any domain there, so we just create some Boolean key string, and definitely if some patent comes from Korea, I have seen that it's in a Korean language, and some lot of patents in the Chinese language. So just we need to in a click we got, because to find the technical field, we need to be go to the each patent descriptions and what technical field it relate to. So within a minute, a second, whole conversion take place in the English language. So it's quite. So in that way, it's really quite helpful. Otherwise, most of the database sometimes we need to be like for the publication, we always struggle in a Scopus and Web of Science database, that we have to relieve these other languages. So in that way, I think it's really a very important feature they embedded in their database.
Yeah,
It's quite
yeah.
important. Yeah.
That's exactly what also we are dealing with very
Yeah.
often.
Yes. Yeah.
Great, thank you. Any other comments or questions? Um,
And please don't hesitate to connect with me. And
yeah,
Anna, if you want, you can share my. And I will love to be here from everyone who wants, whose research is aligned with our group is quite active. You can go to
Yeah.
the Mars group on in the Department of Industrial Engineering. Any one of us are quite reachable. Professor Flores, Professor Ronald Palo, and myself, and we will trying to get back to you.
Yeah.
So it's
That
like
sounds good.
it's
This is
like
also the start of the seminar series for this semester. We have a couple more now. Mm, Yeah, roughly on a monthly basis, we have these seminars, and then we also update
I will
on our
join. I will
website.
join definitely. So because I'm very curious to be learned, because in
Yeah,
several dimension I want to capture the knowledge.
yeah, yeah.
Yes.
I think we can provide a good space, and it's also interesting for us that we're moving a bit from the policy and governance area where we worked in before regarding the biodiversity bonus jurisdiction agreement. We're moving a bit towards the let's say more technical area now with the whole digital twin discussion and research. Yep, but I see. There Mesam also put a comment in the chat, more as an info. Okay. Otherwise, if there are no further questions, I would just make a bit of advertisement here at this space. Thank you very much, Madhulika. Really, it was
Thank you,
an
Anna.
excellent
Thank you for
presentation.
giving me
I learned
opportunity.
so much. I really appreciate it when there's like really concrete examples that really gives flesh to what we always discuss, very abstractly. So I really enjoyed this.
Thank you.
Yeah, thank you very much.
Thank you
Otherwise,
so
I use now this moment and this space to we've done this to now present the rest of the semester. So we will have two more ocean seminars in the semester. One in not a month, but less 3 weeks more or less. And this will be about unlocking private sector data for ocean science by Peter Berger, the Ocean Decade Data Knowledge Manager at UNESCO IOC. And so we stay in this area of data and technology for ocean economy and governance. And then in December, before Christmas, we look into one specific, or we look into data more specifically and discuss with Muri Rabon, who is at the National History Museum in London, relevant databases and practices. So what data bases exist that could underlie DTO, digital ocean for the digital twin for the ocean. And particularly, I know that she has a lot of experience in working with deep sea data and with the ISA database. So I'm sure we will find out something about this. And because we've been recording this, so you can also find our ocean seminars on our YouTube channel, the recordings if you want. And have a look there. And then just, if there are no questions at this stage, I would also invite everyone to participate in our ocean data survey, because at the Twin Politics project, we are also trying to find out how the data and technology is being used maybe at the moment for different policy making and governance processes related to the ocean, but also how it can be used in the future and what sort of the challenges and practices exist in the use of tools and technologies such as digital twins of the ocean. And so, we invite you to respond or to participate in the survey. That really helps us to gather experience and information on how people in the ocean governance and the DTO space are using these technologies and the data and how it could be used. So we're hoping to get a broad picture and to publish then this data, but at the end of towards the end of next year. So that will take a bit of time. We're still collecting the data and trying to get a as wide picture as possible. So this is then from our side, this would be the last advertisement we would, no, not the last advertisement. We still have one more, but this is really only for those that are actually physically in Vienna, because this will happen at the Austrian Academy of Sciences tomorrow afternoon in German, unfortunately. It would be about transformative change. There's the transformative change assessment by the IPBES, and we have sort of worked on translating this for the Austrian context and audience, and this will be presented tomorrow. And I also then, apologize that Alice Vaudreau, our professor, cannot or is here, but very silently because she's a bit sick and she has to save the energy for tomorrow for the big in-person event. Yeah, and with this, I leave it here, and you can always contact us. We're happy if you follow us on or look at our website, fill out the survey, but also look at what we do on Blue Sky or LinkedIn. And if you have new topics or new ideas for the ocean seminar, you can contact Wen. She's been organizing it brilliantly. And as you can see, for this semester, we have an excellent schedule, but the next semester is still open. So if there is anything you would like to discuss, just shoot us a message. Yeah. Otherwise, thank you very much to Nova Scotia on the other side of the Atlantic. And maybe we'll meet each other in person one day. Otherwise, thank you very much for this very insightful presentation. And if there's nothing else to say, I give everyone a free evening.
And thank you, everyone, for your patience and for listening to me. And hopefully, we can come together on some common platform, like if the research aligns, and just keep in touch with me. And I would love to be, remain in touch with you to see that what we can do in the future together. Yeah.
Thank you. Thank you.
Thank you so much.
Thank you to Wen and Philip for organizing all this. And maybe we'll see some of you maybe tomorrow in Vienna in person. Otherwise, keep in touch and see you at the next ocean seminar. All right.
Thank you.
Thank you. Have a good evening.
I think it's a good night time.
Not quite.
Not quite. Okay, good. Still good.
End of the working day. Yes.
Yeah.